specific charge of a particle is charge over mass. The nuclear number is the total number of protons and neutrons in a particle, and the proton number is the total number of protons in the particle. An isotope is a particle which has the same number of protons but also has a different number of neutrons. An antiparticle has the same mass and rest energy as a particle, but it has an opposite charge and spins in the opposite direction. Annihilation is caused when an antiparticle and a particle collide. This then in turn releases two photons, and the energy of the photon is equal to the rest energy of the particle itself, and in this process all the mass is converted into photons. In pair production, a photon is converted into a particle and an antiparticle. This means that the energy of the photon is equal to 2 times the rest energy of the particle which it was converted into. There are 4 fundamental forces: gravity, electromagnetism, weak nuclear force, and strong nuclear force. The strong nuclear force has an attractive force between 0.5 phenometers to 3 thermometers, and the strong nuclear force keeps the nucleus stable. Its exchange particle is a pion. Gravity's fundamental particle is a graviton. Electromagnetics' fundamental particle is a virtual photon. The weak nuclear force is a boson. Hadrons are particles that feel the strong nuclear force, and these are split into 2 categories: baryons and mesons. Mesons are made of a quark and antiquark, whereas baryons are made of 3 quarks. The proton is the only stable baryon. The kaon is a meson and decays into a pion. A lepton is a particle that is not affected by the strong nuclear force. Muons, electrons, and neutrinos are all examples of leptons, and all leptons have to apply to the conservation of lepton number law. There are 3 conservation laws for quarks: the conservation of charge, strangeness, and baryon number. Alpha decay occurs with very large nuclei. The nuclear number decreases by 4, and the proton number decreases by 2 in this collision, and releases an alpha particle of 4 nuclear number and a proton number of 2. Beta decay occurs with nuclei that has too many electrons. The nuclear number stays the same, but the proton number is increased by 1, and you get a beta particle with a -1 proton number, and you get a neutrino. In beta negative decay, the neutron goes up and turns into a proton, and the rest is exchanged via the negative boson and releases a negative beta particle and an antineutrino. In beta positive decay, a proton becomes a neutron, and the exchange particle is a boson and releases a neutrino and a positron. A proton and an electron exchange via the positive boson and in turn release a neutron and a neutrino. In the electron-proton collision, the electron collides with the proton and is exchanged via the negative boson and releases a neutrino and a neutron.